Hello, welcome to this video. We have a really nice equation. X to the power of x is equal to 3. So what is x? So obviously this is a non-standard equation. We're going to start from the results of this equation. So here is the graph of x to the power of x. You see right here, decrease in this range, and here is the local minimum and the increase in this range. So we're going to determine the intersection of this graph of this function with the y coordinates 3. So the first thing is that we need to evaluate the upper limit on both sides. So this side and this side. So here is x tend to be 0 and here is x tend to be positive infinity. So as I have talked about in my previous videos, and when x tend to be 0, x to the power of x is equal to 1, and when x tend to be positive infinity, x to the power of x is positive infinity. So the upper limit on the left side is 1, and the upper limit on the right side is positive infinity. And here is the straight line y is equal to 3. You see clearly that there is only one intersection of the straight line 3 with the graph of x to the power of x. So here is the intersection, and the corresponding x value is less than 2 and is 1 point something. So we are going to figure out this. Let's go back to the original equation, and we take the power of 1 over x on both sides. So then we have x to the power of x, then to the power of 1 over x is equal to 3 to the power of 1 over x. Then we apply the rule a to the power of m, then to the power of n is equal to a to the power of m times n. So say x times 1 over x, and we get something good, that is x. So we have x is equal to 3 to the power of 1 over x. Remember, we have 3 is equal to e to the power of ln 3, and we can replace 3 with e to the power of ln 3, and we have x is equal to e to the power of ln 3, then to the power of 1 over x. So here we can again apply the rule a to the power of m, then to the power of n is equal to a to the power of m times n. So you see here the power is ln 3 and 1 over x, and we can take the multiplication of these two terms, and we have x is equal to e to the power of ln 3 over x. Then, so obviously this is a non-standard equation. So the idea is to use Lambert W function to get the value of x. So you see here is e to the power of ln 3 over x. So we need to make this equation as the format of something times e to the power of something. So we already have the e to the power of ln 3 over 3, and then we multiply both sides with ln 3 over 3, and we have x times ln 3 over 3 is equal to ln 3 over x times e to the power of ln 3 over x. Then you see here x, and here x is denominator, and this will cancel this, this will cancel this, and make arrangements. We have ln 3 over x times e to the power of ln 3 over x is equal to ln 3. So look at this equation. This is something times e to the power of something is equal to something else. So this is the format of Lambert W function. So what is Lambert W function? So if we have a function fa is equal to a to the power of a times e to the power of a. So Lambert W function a is the inverse function of fa. So wa is equal to f minus 1a. So w and f are inverse function of each other. Then w a times e to the power of a. So a times e to the power of a is fa, so it's equal to w fa, since w and f are inverse function of each other. So w will cancel f, and this and then we have this is equal to a. So the number W function is also described as WA times e to the power of a is equal to a. So with this idea, we take number W function for both sides of the equation, and we have number W function of ln3 over x times e to the power of ln3 over x. Then it's equal to number W function of ln3. So you see here, a times e to the power of a, number W function of a times e to the power of a is equal to a, so left side is equal to this part, ln3 over x, so a times e to the power of a. So number W function of this is equal to this part, so ln3 over x, and it's equal to number W function of ln3. Then x is equal to ln3 over number W function of ln3. So at this point, we have already got the final answer. However, if you really want a value of x, and we have to use the calculators. So here, ln3 is equal to 1.098612, and we bring up the number function calculator, and we put this value into the argument x. So x is equal to 1.098612, and we click compute, and we get the number W function value is 0.601829. So number W function of ln3 is this value, and ln3 is this value. So x is equal to this value over this value, and x is equal to 1.82. So here is the final answer to the question, and so here is the value of x. Also, you'll see on the graph, the x value corresponding to the intersection is 1.82. So with that, I have to close this video. Thanks for watching. I would appreciate if you subscribe to this channel for more videos, and we'll see you in the next video. Thanks, bye.